Welcome to Flink Forward Asia 2024.
Kan? Masih semangat, kita lanjut lagi langsung continuing our agenda. We will continue with our third presentation about build a streaming warehouse with Flink and Hologres. Presenting by Mr. Zhong, Big Data Solution Architect from Alibaba Cloud. The stage is yours, Mr. Zhong. You have 30 minutes to go on.
Okay, thank you. Okay, hi, good afternoon, everyone. This is Zhong. I'm from Alibaba Cloud. I'm a big data solution architect. Today, I'd like to share the best practice of building a streaming warehouse by Flink and Hologres. Okay, first, let's have a look at the technical requirements for building a streaming warehouse. So now we see the big data is moving, is changing from the scale to real time. We have seen many real-time use cases like the big promotion, real-time GMV dashboard, and in Chinese Spring Festival there is a streaming live broadcast, and all these use cases depends on real-time processing. So. But compared to traditional batch data warehouse, there is not a consolidated scheme for building a streaming warehouse. Because we know for the batch warehouse, we architect the batch warehouse, we do the layering, but for streaming warehouse, we have no consolidated paradigm. How to architect a streaming warehouse? How to do the layering to make the data reusable, and how to make the data flow across the layers. But I think one principal problem we need to solve is make the data flow transparently and flexible across the layers and make the data usable. So let's first have a look at some traditional options to build a streaming warehouse. So option one, we call it streaming ETL. That means we build the layer in a message queue like Kafka. And we ingest data from that source into the ODS layer, and we building Flink pipelines and to do the data transfer from ODS to DWD and to the DWS. And for the use case of the query, we will use KV store like the HBase or Redis to provide the data queries to the applications, and to leverage the data query and data exploration. We usually make the Kafka's data sync into an OLAP engine for detailed data exploration. This architecture actually brings some pros and cons. The pros is clear. There is a clear data layering from ODS, DWD, and DWS and ADS. And also, there is a clear responsibility for the data store and data pipeline. But the cons is also very clear. We need to build the stream pipeline, and that requires extra resource and cost. And also, because we store the data in Kafka, generally speaking, is not easy to do data exploration. So that's why we need the data replication in an OLAP engine to explore the data. And also, because the data is located in the Kafka and OLAP, it's very difficult to keep the data consistent. Okay, next option, we call it streaming loading and ad hoc query. And the methodology is simple. We just ingest data and load this data into an ODS layer. And we do not do the layering. And once application comes, we build the query based on the ODS data. So the the process is agile and flexible. Just ingest data and do the query. And it's low cost and easy for data correlation because all the data is located in the OLAP, in the streaming warehouse. But the cons is also very clear. For some complex queries, it usually brings poor performance, especially when the data grows. And there is no layering, so that makes the data reuse difficult. There is a new application. We built the query from the ODS. We cannot reuse the data or models. And data, yeah. So for option 3, we call that streaming loading and batch processing. Yeah, this methodology is we load the data streaming by Flink, like Flink CDC, and into the streaming warehouse. Then we have a separate system, similar with the batch system. We schedule the jobs and do the batch processing, do batch calculating, and aggregation. And also, we have the models in the stream warehouse. The process, we can adopt the matrix scheme, similar with the batch system. We already have the batch system. We have the batch scripts. We can reuse that. But the cost is also clear. There is a latency from the end to end. From the source, because we use the batch processing, that brings long latency for the data refresh. Option 4 is clear. We call it, we leverage materialized view to build the stream warehouse. Yeah. It's some kind of similar with the option 2, streaming loading and ad hoc query. But for the ad hoc query, we use the materialized view to build the models. The process is some kind of near real-time end-to-end pipeline. And the results of materialized view can provide a better performance. But the cost is also clear. There also has some data inconsistent. And also, materialized view brings extra cost. And for storage and computing. So, do we have a more better solution? Yeah, let's have a look at Hologres. Hologres is an Alibaba Cloud native real-time data warehouse. It's targeted for provide hybrid serving and analytics scenarios, like the OLAP analysis and KV queries and data lakehouse within one product. It's a hybrid product, provide support multiple analytics use cases. So, yeah. So let's see the capability provided by Hologres. First is the real-time. It's for the OLAP analysis. It provides high performance data updating, high performance data ingestion, and high performance, especially high performance for the KV queries. And also, it provides a good performance for the OLAP engines. We know for the analytics scenarios, we usually use the collinear storage. So that provides a better data processing. Yeah, and also we have a benchmark. We ranked #1 in TBC 30 terabyte performance benchmark. Yeah, that's the proof for the high performance. Next is the data serving. Yeah, data serving, we can provide the millions QPS KV query. And also we provide the Proxima engine, which can provide a vector retrieval. Yeah, it's usually very useful for the unstructured data vectoring and query. And for this scenario, we usually use the raw storage. Hologres provides different storage type, collinear storage and raw storage. So for the tethering scenario, we suggest using the raw storage that performs high QPS KV query. Yeah. Next is the lakehouse. Lakehouse, Hologres we can provide query acceleration on the lakehouse. The lakehouse include the Alibaba Cloud Native Data Warehouse Max Build and also lake storage like the OSS. So by Hologres lakehouse capability, there is no movement from the batch warehouse or the lake storage to Hologres. It's only the metadata synchronize and Hologres can query data on the lake or on the batch warehouse directly and provide affordable performance. Yeah. So Hologres also because we are targeted for a real-time data warehouse. Data warehouse is always famous for its enterprise capabilities. Hologres also provide the enterprise capabilities like the data masking, data security. We provide the PG circle compliant syntax. And for PG circle syntax, we know there is a very mature security and access management. And we can use this access management to manage the user rules or roles in the warehouse. Yeah, like the IP whitelist and data access control, data backup and recovery. And for observation and troubleshooting, we also provide the log query and it helps explore the root cause for the slow queries. Okay, after introduction of our cloud-native real-time data warehouse Hologres, let's see how to build a streaming house with the Flink and Hologres. Let's first have a look at the integration between Flink and Hologres. So first, Hologres can be used as the dimension table of Flink, and it provides a high performance data read. Because in Flink, we usually have the dimension join scenarios that require the high read performance for the dimension table. And also, because Hologres can provide real-time update for the dimension table, so that makes the dimension table data refreshed quickly and in time. And also, Hologres can be used as the result table. So we can, after Flink processing, we can sync the result into Hologres. Here, Hologres provide high performance for data insert and data update. And Hologres can provide the whole record level update and also the column level partially update. So that makes the data update more flexible and suitable for multiple use cases. Okay, and yes, so it's usually very useful for the white table update scenarios because, for example, we have multi-string join and we have dimension join, and we want to insert the results into a white table. And we can leverage this feature to do the update in the white table. And also, Hologres can act as the source table. Here, yeah, before we discuss about the CDC, and before we discuss several schemas to building a streaming house, the major disadvantage is the low latency. It's the long latency. Is the latency, but by leverage Hologres CDC capability, we provide a change data feed. That means Hologres can provide the bin log. We can fetch the bin log from Hologres and build an event-driven streaming pipeline. And also, we provide the Hologres catalog. Within the Hologres catalog, we can manage the Hologres metadata, and we can achieve the schema evolution from the source to Hologres. That means once the schema change in the source, and we can sync the DDL, and the schema catalog can adapt to this schema change. Yeah. Okay. So let's see how the reference architecture to build a streaming warehouse. Here is the data source, and we leverage the Flink CDC to synchronize data into Hologres. And here is the ODS layer, and by enabling Hologres bin log, and we can build an event-driven stream pipeline and get the change data, and to do incremental computing, and we can build the DWD here in Hologres. And also, by enabling bin log, we can build a streaming pipeline to build the DWS. So all the layers are located in ODS, are located in DWD and DWS in Hologres. And all this processing is real time, it's event driven, and and it's low latency. Yeah, and because now the data is flowed in real time cross layers in Hologres, so this resolves the key principal problem. Yeah. Before, in the option 1, Kafka's data is not easy to query, update, and fix. And because we built layers in Hologres, and for each layer, the models can be reused by the applications, by the data analysis for query. Yeah, that's the general introduction for this reference architecture, and we will give a more detailed use case and practice in the following slides. Yeah, here is the solution highlights, and the highlights, I think, it's mainly depends on these 3 features provided by Hologres. First is the bin log. Yeah, it's the change data feed capability provided by Hologres. Second, Hologres support hybrid storage. We support columnar storage and row storage, so that make Hologres support multiple use cases and data analysis scenarios. Yeah, the third point is the resource isolation. Why we mention the isolation is very important, because for Hologres instance, we support different analytics scenarios. We have KV, because KV is usually serving for the online transactions. If the resource is occupied by other query, that will bring bad impact on the KV queries. So we need a strong resource isolation to separate different scenarios and make Hologres stable and high available to the downstream applications. Okay, now let's have a look at the streaming warehouse practice. So the scenario is we have e-commerce application, and the data source have several orders, shops, and users. And we want to build a streaming warehouse. And in this streaming warehouse, we want have data layering, and we want to have real-time data processing, and the streaming warehouse will serve the applications of recommendation and dashboard and self-service queries. Oh, sorry. So the general data flow is we use the Flink CDC to capture the data from the MySQL data source. And the ODS is it's the same with the data source, yeah. And from ODS to DWD, we use the Flink to do multiple source to do the table join and generate the results and do update on the DWD details data. And also we do a dimension table join. The orders join the product catalog to enrich the data and sync the result into one wide table, DWD orders. And next is we use Flink jobs to do the summarize on DWD tables and generate the features, users features and the shops features to serve the downstream applications like the recommendation and ad hoc queries. So let's see the step-by-step procedure. First step, we do ODS return synchronization from data source. And all these steps can be achieved, implemented by simple circles. So here we leverage the Holo catalog. We create a Holo catalog, then we just use the syntax create the database as. So by this simple circle statement, we can achieve the whole database data synchronized from the source to the ODS layer. And this circle syntax can achieve one-time full data synchronized and real-time incremental data synchronized. That makes the ODS data the same with the original data in real time. Yeah, keep the same. Next, we do a DWD layer building. And here we have two circle script. One is do the dimension join. Yeah, we first create the DWD table, and then we have a circle script. One is do the dimension table join. Another is do the select some field from the orders pay, and all these two Flink script will do the update on the DWD orders. So before we know that we have several scenarios. We want to do multiple stream join. We have a lot of upstream tables. And when we want to achieve multiple stream join, it's usually complex. We need to join a lot of tables. But by leverage Hologres partial update, we can separate this multiple stream join into two circle scripts. Yeah, two snippers. And for each snipper, we can do just do a table join. For example, the source join with the dimension table and select some to do filtering and to do the table updating. Yeah. Here is the example to build the DW layer tables. Next, we build the DWS aggregation tables. Yeah, we have two aggregate table. One is the users and another is the shops dimension. And we can do the aggregation according to our business logic. After we build the DWS layer table, then we go to the application. Yeah. So there provides several kind of applications within one Hologres instance. So for the Hologres recommendation, we can, because for the recommendation scenario, we need to query the feature store. Yeah, users feature store and the shops feature store, and then we can do the real-time recommendation. And also for the self-service, we can provide filtering, and we from the DWD details data. So that provides more flexible for the applications to do the query, because we can do from the DWD white table, and the white table have the full information. We can query from the DWD details table. Yeah, that's for the OLAP and the self-service analytics scenario. And yeah, one question is how to do the troubleshooting. Yeah, before, if we set up a separate platform for real-time and a batch system, if we store data in Kafka message queue, it's really difficult to do troubleshooting. But now we are in the Hologres. Hologres is a real-time data warehouse. It supports SQL query and a powerful SQL syntax, so we can make the troubleshooting, make the data exploration more flexible and more easily, more simply. Yeah, we can see in Flink, we can use the stream mode or batch mode. And for the stream mode, we can see the change logs. And for the batch mode, we can see one snapshot at one moment. Yeah, we can see the result at some point. Both can support our data exploration and troubleshooting. Okay, finally, let's sum up. The key takeaways, I think, from the practice is, first is one stop. We do not want to build a very complex system. So by leveraging Flink and Hologres, these only two components, we can achieve a streaming warehouse architect, which can support multiple use cases and data analytics. And also in the streaming warehouse, we build the layering that make the data models can be reused and reduce the redundancy. Next is the high performance. Hologres is targeted for real time, so it provides powerful real time capability in data ingestion, data update, data serving, and data query. The last aspect is enterprise level. Yeah, it's a real time data warehouse, provide the rich enterprise capabilities, and which will make our data warehouse building and operation more simple and more easy. Okay, that's all. Thank you.
Very much, Mr. Chris Zhong. Thank you very much.